I'm going to show you another way to try and 3D print your protein, which will give you more of something that looks like a backbone rather than the surface view, which is from this other screencast. So first I'm going to go to my PDB homepage, and I'm going to type in my protein. I'm going to do one of my friend's proteins that she crystallized called cereblon. And yep, this is it, 5V30. On this protein, here I'll make my screen a little larger. On this protein, as I kind of scroll down, I can see that there are multiple chains. So here's the first chain, chain A, which is DNA damage binding protein 1. And here's chain C, which is the protein cereblon. That's the one I actually want. And there's two things that are binding to that cereblon molecule. So that's how you can see which chain you're interested in. So this has multiple chains. I'm interested in chain C. And I'm going to go over here, download files, PDB format. Click that. Oops. And you can see in my downloads now, I will have this B30 protein. So instead of using that Jmol feature that I showed before, there's another online way that you can do it, which is this website, which is http://cbm.msoe.edu/science-olympiad/prebuild.html. So I'm going to go there. And this opens an interface. It's a little similar to Jmol, but some people might find it a little more user-friendly. Other people might find it harder. So here is the molecule and this is not my molecule. This is just a molecule that the Science Olympiad teams were working on. And you can see you can click and drag and move that. But I don't really care about their protein. I care about my protein of interest. So I'm going to press on a Mac, Control-click. On a PC, it's probably just a left click or right click. And I'm going to Control-click, go to File, and I'm going to load. And I'm going to load from PDB here. Let's see. And it's going to choose file. So I'm going to go into my downloads, and it's this first file that I just downloaded. I'm going to click that and press load. And that will open my protein. And you can see, you're like, oh wow, there's a lot of stuff. What in the heck do I do? So I'm going to show you a few commands that I think are really very useful. So the first thing is that I want to hide my chains that I don't want. So for example, that chain A, that DNA binding protein, I don't really care about that. So I'm going to go to select:(A). That's going to select, I'm going to try that again. And you can see there are 8,000 atoms selected. So that's the whole chain A. So I'm going to say I want the wireframe to be 0, and I want the space fill to be 0. And then that removes it. So now I'm left with only chain C, which is the one I care about. So this is my chain of interest, and I can kind of change the way it looks. And the thing that I think is the most helpful, because I want to be able to see alpha helices and beta sheets. So I'm going to go to select:(C), so that's going to select this molecule here, the C chain. And then I'm going to do space fill off, right? And that you can see that kind of changes, and now we just have these wireframes. But I also want the wireframe off, right? Now we have nothing. Wait a minute. But, so if we go back to select:(C), that's going to select my C chain molecule again, and now I want to look at the backbone only. So I'm going to do backbone 1.5, and that will give you my carbon that is the carbon backbone. So you can see parts of the secondary structure here. So I can see alpha helices. I can see right here we have some beta sheets. But it kind of gives you a look at your molecule, just at the backbone. So this is another way you can 3D print your protein rather than looking at the surface view. A few more things that I think are interesting is that I would like to, for example, color my alpha helices. So I can do select helix, and I'm going to color, well, let's make it green. I'm going to color them green. So those are all the alpha helices in my protein. I'm going to also do select sheet. This will do the beta sheets, and I'm going to color that red. Right? So you can see now there's these different secondary structures within this tertiary structure of the folded protein. When we 3D print, we're not going to see differences in these colors, but if we 3D print in white, we can then go back and kind of use a Sharpie or nail polish or something to color those ourselves. But for me, it's just nice to see those. In this particular protein, there is a binding site, the active site, which is really important. And from reading some papers, I have figured out exactly which 4 amino acids are crucial. So I'm going to actually highlight those. So I'm going to do select :A. I'm going to look at only the A chain. Oops. No, I want to select :C, right? I only want to use the C chain. My bad. Then I'm going to say select, and it happens to be glutamine, amino acid 377, and side chain. So that highlights 5 atoms, which is that glutamate amino acid, and I'm going to space fill at 1.25. Let's see. And you can see there it kind of popped out, but I'm also going to do wireframe 1.0. Didn't seem to do much, but I'm going to color this yellow. So there's my little first amino acid. Let's do the other ones now. So select, I know it's histidine 378 and side chain. And I'm going to space fill 1.25, and I'm going to color that yellow again. All right, so we're starting to see the active site, the pocket, where it's going to bind its substrate. So the next one I'm going to do select proline 352 and side chain, and I'm going to do space fill 1.25 and color yellow. All right, so there's the third one, and I'm going to do my last one. Select histidine 353 and side chain, and I'm going to do space fill 1.25 and color yellow. All right, so now that really shows you the specific amino acids that would bind the substrate. So that is the active site. So this is one way to kind of highlight where your protein of interest is going to bind its substrate. So for example, this molecule, cereblon, is an enzyme, so its substrate will bind here. It will act on that through interactions with these 4 amino acids, which I've highlighted. And again, we can't get color when we 3D print these, but it's really nice just to have this for me. All right, so the next thing we're going to do is export. So I'm going to go over here again and do Control-click, or on a PC, it's probably going to be your left or right click, export. So we're going to export as, I'm going to do this X3D 3D model. And here, I think it's really important to name this, something that you know. So I'm going to name it cereblon, which is the name of the protein, and I'm going to name it test. So that's the one we're going to use. So I'm going to press OK, OK, and you can see it's going to go into my downloads. All right, once we have that, now we can use some other programs to try and get that into a format that is useful. For me, the program that I have found most useful is this, again, free program called Blender. So I'm going to quit Blender, show you what it looks like when I open it. So let's go find Blender. And I'm the first to admit that I do not understand how to use Blender really well yet, but I know how to use it just for the purposes that we need. So here we are going to do File, and we are going to import right here this .x3d. I'm going to import that, and now we have to go find it. So mine were in the downloads, and I don't see it, so I'm going to search for it. Cereblon test. That's the one we want. Double click that, and here's our protein. And you can zoom out by kind of pinching your fingers on the mouse, and you can see it looks pretty large and in charge. So great, I don't really care what it looks like. All we're using Blender for is to export as a .stl. All right? So here it comes. That's fine, it's just gonna go here in my computer. Let's see, can I put it in my downloads? And again, instead of untitled, I'm gonna call it Sarah Blonde Test, but now it's gonna be the STL. I come over here, click STL. Sorry, click Export STL. And it did something. So I'm going to minimize. Let's go to my downloads. And there it is right there. All right. So I have a couple programs on my computer that we can use, but in general, that is one way to get it to an STL, which then you can use to 3D print. All right. We can stop the movie there.